Question 3 to tutorial 6. In this question, we have water is flow out and overheats water tank through a smooth pipe opening at ground level, as shown in the figure below. The bottom of the tank is 20 meter. The bottom of the tank is 20 meter above the ground level, while the depth of the water in the tank is 5 meter. For example, in this tank, water level here, and water level is in this tank is 5. The pipe diameter, this one, is 50 millimeter or 0.05 meter. Okay, you have to find the water flow rate expected at the ground when we ignore the losses, assuming the constant water level is maintained. We have to find the water level. It means we have to find volume flow rate. To find volume flow rate is similar to question 2. We have to know the velocity and the cross-section area. Okay, velocity and cross-section area. In this case, we can we have, for example, I have the point on the water surface is point A, bottom meter is B, the ground is point C. Because you see in the question we have assuming the constant water level is maintained, it means the capacity of the container is very big compared with the amount of water flow out of the container. Okay, so for this one it means we can assume as the amount of water in the water tank is constant. Okay, so to find the water flow rate, we have to find velocity and cross-section area at point C, not point A or point B. Okay, point C, and similar to question 2, to find velocity, we have to write the energy equation. So to write energy equation, we have to choose 2 points. In this case, we find velocity at point C. So one point is point C, and another point is point A or point B, or any point between A and C. Okay, as you see in the energy equation, we have pressure, we have velocity, and we have Z. Okay, so for point B, is this point we don't know velocity. Z we can find Z of point B, but velocity we don't know. But at point A, we know everything about point A because point A is the water surface, and this one is open water tank. So it means the pressure at the water surface will be equal to atmospheric pressure. So PA will be equal to atmospheric pressure or 0 pressure at A. VA, velocity on the surface of a big container, we can assume is 0. Is 0 meter per second for the big container. Okay, and that's A. If we assume as Z0 on the ground, that's 0 here, so you will have ZA is 25 meter. Okay, so you see we know everything about point A, pressure, velocity, and Z. That's why we write energy equation between point C and point A. Okay, so energy is point A, PA over rho Z, VA square over 2Z, ZA equal to PC over rho Z, VC square over 2Z, ZC. With PA, as I said, PA is 0. VA, the velocity on the surface of a big area, or the big container, we can assume is 0. This one is 0. ZA we have here is 25 meter. Okay, now we have a look in the energy at point C. At point C, PC. How about PC? because we have smooth pipe opening at the ground level. Okay, it means it's opening at point C. When opening at point C, PC will be equal to atmospheric pressure. Okay, or PC will be equal to 0 gauge pressure, and ZC is 0. Okay, so that's why we have BC will equal to square root 2 gravity and ZA. ZC is 0. Or equal to square root 2 times 9.81 times 25. So we have velocity. What our velocity at point C is around 22.15 meters per second. Okay, and when we have velocity, that's easy to find volume flow rate. Volume flow rate equal to velocity at point C times cross section area at point C. With cross section area at point C, area at point C we have is smooth pipe with the diameter is 0.05 meter. So AC will equal to pi d square is 0.05 square over 4. Okay, so from this one we will have volume flow rate will be is 0.0435 meter cube per second. Thank you.